Bismillahirrahmanirrahim. In this session, we will discuss exercise 15.8, question number 3. For this, we have given this definite integrals with the limits of 0 to 1 for e power 2x dx. So we will solve this integral, and it is obtained as e power 2x divided by this 2 in the denominator, and we put the limit here, and on substituting the limit it becomes half e power 2 minus e power 0. E power 0 is 1, so 1 over half e square minus 1 bracket close. So secondly, for this d part, e power 1 minus 3x and 0 to 1 by 3. So this e power 1 is odd side, and e power minus 3x is integrating here from 0 to 1 over 3. So this is e is constant, and this e power 3x divided by minus 3. So because of this minus 3, this is minus 3, and then substituting limit. So this is minus will here, and e power 3 1 over 3 and e minus 3. On substituting limit, this becomes e power minus 1, and this is 0, which is 1. So e power 3 1 minus this minus sign change, so this becomes 1 and inverse here. And on simplification or substitution rearrangements, and we have obtained this as a result. Similarly, for this g part, we have e to 0 to 1 limit e power x plus e power 2x whole square dx. On the opening this a plus b whole square, this becomes this, and on solving individual integrals, this part is here and this part is here, and then substitution. On substituting the limits, we get this result. On simplification, we have obtained this result, and finally we got this result. Similarly, for this I part, we have 0 to 2 limits, 3 plus 8 e power 2x divided by 2 e power x dx, and from this division we have 3 by 2 e power minus x, and from this division we have 4 e power x. And on solution of this integral for this part and this part, we have obtained this for this integral, and for this part we have this. On substituting the limits, we have obtained this as a result eventually. Similarly, for the fourth part, so we have to evaluate 0 to pi sin x dx, and on integrating this trigonometric function, the sign becomes minus cos, and from limit 0 to pi, so this minus is here, and this cos is pi, cos pi minus pi 0. This cos pi is minus 1, and this is 1, so minus 1, so this becomes minus 2 and minus plus. So for this part, 0 to pi by 2, 3 plus 2x dx, this is 3x, and this is sin 2x by 2. Integral of this cos 2x is sin 2x divided by 2, and then substituting the limit, we have obtained the result as this is 3 by 2, this is sin pi by 2 is 0, this is 0, and this is 0, so 3 by 2 is answer. Similarly, for this e part, 2x minus sin 2x dx, 0 to pi by 4, this 2x is 2x square divided by 2, the sin 2x is cos 2x divided by 2, the limits is 0 to pi. Substituting the limits, this 2 will cancel this 2, x square plus cos 2x by 2, 0 to pi by 4. On substituting the upper limit here and then lower limit here, solution, we have obtained this. Similarly, this fifth question, we have 0 to pi 2 divided by 3x plus 1 dx. For this, this is ln x function, this is 2, 3x plus 1 is ln x 3x plus 1, and this 3 is here. And I'm substituting the limits, and we have obtained results as 2 by 3 cos ln 16 by 4, so this is ln 4 by 3. Second part, and this is the d part, minus 2 to minus 1, this is 5 2x plus 1 dx, so this is 5 by 2 ln x 2x plus 1 minus 2 to minus 1. On substituting limits, on simplification, we have obtained the result as 5 by 2 ln 1 upon 3. So this is ln 1 minus ln 3. So this ln 1 is 0. So this is minus 5 by 2 ln 3. Solve this question number 6. The limits is 0 to 4. 1 plus 2 3x minus 1 dx. So this, on solving, this is dx, and this is the other part. On solution of this integral, we have obtained this result, 0 to 2 to 4, and on substituting, we have obtained this result, and on simplification, we have obtained this. Similarly, for the c part, 3 plus 1 over 5 by minus 2x dx, so this becomes 3x, this is ln 5 minus 2x divided by minus 2, this is minus 2x square divided by 2. On simplification, we have obtained this, limits 0 to 1, and substituting the limit, we have obtained this. On simplification, this was question number 6. Now we solve the question number 7. We have 1 to k 2 3x minus 1 dx is equal to 2 upon 3 ln x 3x minus 1 1 to k. This becomes, on substituting the limits, we have obtained this, and this becomes, so this is given, so this 3k minus 1 upon 2 is basically the 7, and k is obtained as 5. So this was very important question. For 8x, we have 4x upon 2x plus 3. So we divide this one to make it rationalize. It becomes 2 plus a upon 2x plus 3. On simplification, we have this a is basically minus 6, and this a part is obtained as minus 6. And on integral, this part and this part is 2x, and this is 6 upon 2 ln 2x plus 3, and limits is 0 to 1. On substituting limits, we have obtained results as 2 minus 3, and this is ln 5 upon 3. Similarly, other parts can also be solved, and in the next section we will solve exercise 15.8.